In this lesson, we continue improper integrals, but a different type of improper integrals. Suppose we have a function f of x, and we want to integrate from a to b. A and b are numbers. Sometimes it's possible that f of x is unbounded near a or near b. In other words, sometimes the limits of f of x when x approaches a, since a is the beginning of the interval from a to b, look at here on the real line, from a to b. So over that interval, approaching a is from the right side. As you have seen in Calc 1, we put a plus sign on the upper right corner of a, showing that x approaches a from the right side. So sometimes this limit is plus infinity or minus infinity. This creates a new type of improper integrals. Or it's possible that uh, or the limit of f of x when x approaches b, on that interval, if x approaches b, it would be from the left side of b. So I put a negative sign there. That negative sign on the upper right corner of b, it means that the direction of the approach, as you have seen in Calc 1. So sometimes this is plus or minus infinity. In such situations, we deal with an improper integral. So this improper integral is different from the improper integrals we have already studied in the previous videos. Okay, now let's see what we should do in such situation. So suppose the limit of f of x when x approaches a from the right side is plus infinity or minus infinity. Then to find the integral from a to b, in an actual example, a and b are given numbers. I replace a by a letter like c, and let c tend to a from the right side. And I calculate the integral from c to b of f of x dx. So after calculating the integral from c to b of f of x dx, we get something in terms of c, and then I let c tend to a from the right side and find the value of the integral. In a similar manner, if the limit of the function when x approaches the other limit of the integral from the left side, so when x approaches b from the left side is plus infinity or minus infinity, then to find the integral from a to b of f of x dx, this is, for here, I replace b by a letter c and then let c tend to b from the left side. So in this case, I calculate the integral from a to c. I get something in terms of c, and then let c tend to b from the left side. In these cases, if at the end the integral is an is a finite number, the integral is convergent. Otherwise, it is divergent. So for instance, if I get the value of the integral to be plus or minus infinity, that's definitely divergent. So if the value of the integral is a finite number, the integral is convergent. If that doesn't happen, it is divergent. So if the value of integral is a finite number, the integral is convergent. Otherwise, it's divergent. Of course, we need to clarify this concept with several examples. So in this lesson, we do several examples to clarify this type of improper integrals. Let me start with a simple example. Suppose you want to find the integral from 0 to 1 of 1 over x dx. This is an improper integral. Why? Because when x approaches 0, the starting point of the interval of this integral, 1 over 0 is undefined. And when x approaches 0 from the right side, I get plus infinity. So at 0, there is a problem. The function is discontinuous. So that's why to find this, I need to replace the number which there was the problem is 0. So I replace 0 with c, a letter c. So the integral from c to 1 of 1 over x dx. After calculating this, I let c tends to 0 from the right side. Why? Because the interval is from 0 to 1. So 0 to so from 0 to 1. So that c should be inside the interval and approaching 0. That's why it is from the right side. C is on the right side of 0. Okay, now this is quite simple. The limit c tends to 0 from the right side. Antiderivative of 1 over x is ln of absolute value of x. And I should evaluate at these limits of the integral and do the subtraction. So it is, so at this point, I don't apply the limits. Ln of absolute value of x at 1 is ln of 1. At c, it is ln of absolute value of c. But since c is more than 0 and approaching 0 from the right side, I don't really need absolute value, just ln of c. What is ln of 1? ln of 1 is 0. How about ln of c? If a number approaches 0 from the right side, ln of that tends to what? I hope you remember this from Calc 1, that this is going to be minus infinity. Let me very quickly remind you the graph of ln. The graph of ln, maybe you have even seen that in pre-calculus. Looks like this. So when a value tends to 0, if value is close to 0, the value of the logarithm goes all the way down, becomes minus infinity. And minus infinity is plus infinity. So if I had to choose between these two answers, convergent, and the value is this finite number, and divergent, since I got infinity, I definitely need to choose divergence. For this example, I don't need to enter anything inside that box because the box here is for the case it is convergent. If I got a number, a finite number, I had to enter. I was required to enter that number inside that box. But this was a divergent integral, so I don't need to enter anything there. Let's do another example. Please try this example on your own. Again, let me keep the limits of the integral simple from 0 to 1 of 1 over radical x dx. And at the end, I want to decide that whether it is convergent, and the value is a finite number, or is it divergent? Please pause the video and try to do this on your own before watching my solution. So here again, I see that the problem is at 0 because at 0 I face the situation of 1 over 0, undefined, and I need to use that definition. Since 0 was the problem, I replace 0 with c, 1 remains as it is, and find this integral. At the end, I find the limit of what I got for the evaluation of that integral as c tends to 0 from the right side. For now, we don't apply the limits until we find that integral and evaluate the integral at the limits of the integral and do the subtraction. Do you remember what was antiderivative of 1 over radical x? Just as a reminder, radical x is x to the power of 1/2. Therefore, 1 over radical x is x to the power of minus 1/2. And if you use the power rule, you have seen this even in Calc 1, that using the power rule, we get 2 radical x. So antiderivative of 1 over radical x is 2 times radical x. And I need to evaluate at these numbers, c and at 1. So the limit as c tends to 0 from the right side. The evaluation of 2 radical x at 1 is 2 radical 1. At c is 2 radical c. Now, when c tends to 0 from the right side, if I replace c by 0, I get just a 0 here. But 2 times radical 1 is 1, 2 times 1 is 2. So I get the value of 2. Therefore, I should enter 2 here. It was a finite number, and the integral is convergent. So in this situation, I have to enter that value because it's a finite value. Let's do another example. Again, I suggest that you pause the video and try to do the example on your own before watching my solution. The integral of x to the 5 over x to the 6 minus 1, and x runs from 0 to 1. At the end, I should decide whether convergent, and I enter the value here, or just divergent. For the divergent case, I don't need to enter anything here, unless the question says that if it is divergent, is it plus infinity or minus infinity, something like this. But if it doesn't specify that, if it turned out to be divergent, we just choose B. If it turned out to be convergent, we need to choose A, and also we need to enter a number inside that box. So before doing this integral, let's remind ourselves that at the beginning that we have problem at which of the limits of the integral, from at 0 or at 1. Obviously, the issue is at 1, because at 1 the denominator becomes 0. And we have, if I replace x by 1, I will have 1 on the top and 1 minus 1, 0 at the bottom. So that's the problem. That's what makes this an improper integral. So in this situation, I need to replace 1 by a letter c. And as I explained before, if the upper limit of the integral is replaced by the parameter, then c approaches to that numbers from the left side. Because again, from 0 to 1, the interval over which we are integrating. So c is between these two, but it should approach 1. So the only way that it can approach 1 is from the left. But before continuing, let's see what is the integral of. We can easily define that by substitution. What is the integral of x to the 5 over x to the 6 minus 1? What technique do you suggest? Obviously, we should use substitution. Let's find this integral first. So if u is x to the 6 minus 1, the derivative of u with respect to x is 6x to the 5. So du is 6x to the 5 dx. In other words, x to the 5 dx is du over 6 if I divide both sides by 6. Why I divided by 6? Because in this integral, I have x to the 5 dx. I don't have that 6. And this is du over 6. And this is u. So this becomes the integral of 1 over u du over 6. Over 6 is like 1/6 has been multiplied by the integral. I can pull it out. So this becomes antiderivative of 1 over u is ln of u, or ln of absolute value of u, plus a constant, and meaning that in terms of x, it is ln of, what was u? U is x to the 6 minus 1, absolute value of x to the 6 minus 1, and plus a constant. Since we are dealing with the definite integral, that plus constant is not needed. So let's go back to the evaluation of this integral. It is 1 over 6 ln of absolute value of x to the 6 minus 1 should be evaluated at 0, and C. Okay, now before applying the limit, I should evaluate this function 1 over 6 times ln of absolute value of x to the 6 minus 1 at C, which becomes 1 over 6 ln of absolute value of C to the 6 minus 1 minus evaluation at the 0, which is 1 over 6 ln of absolute value of 0 to the power of 6 is 0, 0 minus 1 is minus 1, and absolute value of minus 1 is just plus 1. So let me write this plus 1 here. Obviously, ln of 1 is 0. Now, everything will depend on the first term. But when C tends to 1, C to the 6 will be tending to 1, and this tends to 0. And ln of, and you have absolute value, ln of something positive but extremely close to 0 will be minus infinity. We just talked about the curve of ln, that when the value, this curve here, when I have a positive number very close to approaching 0, that means that ln is minus infinity. So for that reason, this ln is going to be minus infinity. And 1/6 of minus infinity is minus infinity. So I got minus infinity, therefore the answer to this question is it is divergent. Just as a clarification, that 0 that you see here, in fact, c to the 6 minus 1, that approaches 0. So that's why ln of that becomes minus infinity. So this tends to 0, tends. That's why ln of that becomes minus infinity. Okay, another example. The integral from 0 to 3 of dx over radical 9 minus x squared. And I want to know that, is it a convergence? If so, what is the value? Or B, is it divergent? I want to decide which one is the case. Now let's see the problem with this function, 1 over radical 9 minus x squared. Is it 0 or is it 3? Obviously, the problem is at 3, because at 3, under the radical becomes 0, and 1 over 0 is undefined. So there is a problem at 3, which makes this an improper integral. So this is going to be equal to, so I replace 3 with C. And since I replaced the end of the integral, the upper limit of the integral, by replace it with C, I need to let C tend to 3 from which direction? From the left. because it is the upper limit. For the upper limit, C tends to the upper limit from the left. If the problem was with the lower limit, then C tends to the lower limit from the right, as we have seen in the previous examples, the previous two examples. So over here, first I need to take care of that integral. This is something that we have done in the trigonometric substitution. Do you remember when we had something like a squared minus x squared under the radical? We use the substitution of a equals sine of t. I don't want to repeat that, but if you remember, refer to the and go back and take a look at those kinds of techniques that we use for the integrals like that. The integral of 1 over radical 9 minus x squared is going to be sine inverse of x over 3. Sine inverse or arc sine of x over 3. And it should be evaluated at these values. And then we apply the limit. Okay, now the limit as c approaches 3 from the left side, sine inverse of x over 3 evaluated at c becomes c over 3 minus sine inverse the 0 over 3, which is just a 0. From pre-calculus, do you remember what was sine inverse of 0? That was quite simple. It is 0. How about the other one? Any suggestion? The other one would be when c tends to 3. Let me replace c with 3. So it becomes 3 over 3, 1. What is sine inverse of 1? It is pi over 2, or 90 degrees. But as you know, in calculus, we use the radians, not degrees. So this is pi over 2. So the answer to this integral is the number pi over 2. So it is a convergent integral, and the value is pi over 2. Okay, let's see another example. Again, as usual, try to do examples on your own before watching my solution. The integral from 1 to 3 of 1 over x minus 1 to the power of 5 halves dx. Again, I want to decide that whether it is a convergent integral and the value I should enter in this box, or it's just divergent. So that's what the problem is about, convergence or divergence of this integral. In the case of convergence, I need to enter the number inside that box. Okay, let's see. What is the problem here? Is the discontinuity at 1 or at 3? Obviously, it is at 1 because in the denominator I have x minus 1 to some power. So to do this improper integral, we replace 1 with c and let c tends to 1. Since it is the lower limit of the integral, I use a plus here because I want to show that c tends to 1 from the right side. So before continuing this, let's find what is the integral of 1 over x minus 1 to the power of 5 halves. This is a simple integral, of course. We let u be x minus 1. Then du over dx is 1, so du is dx. But this advantage of this substitution is instead of x minus 1 here, we have just one letter u, and dx in this substitution is the same as du. So therefore, the integral becomes 1 over u to the power of 5 halves du. Using the power rule, 1 over u to the power of 5 halves is the same as u to the power of minus 5 halves, right? I want to use the power rule. And antiderivative of u to the power of minus 5 halves is u to the power of minus 5 halves plus 1, u to the power of minus 3 halves over minus 3 halves. Over minus 3 halves is the same as multiplying by minus 2/3. And plus c, but that constant is not needed because we are dealing with a definite integral. So if I go back to the original variable here, minus 2/3, let me write it here. Minus 2/3. U to minus 3 halves when moved to the denominator to avoid negative exponents is u to positive 3 halves. But what is u? U is x minus 1. And that's constant. So the integral is minus 2 over 3 times x minus 1 to the power of 3 halves. So let's continue our calculation here. So I will have the limit as c tends to 1 from the right side. That antiderivative we just calculated was minus 2 over 3 times x minus 1 to the power of 3 halves. Evaluated at the limits of the integral. So the limit as c tends to 1. At the 3, it is minus 2 over 3 times. 3 minus 1 is 2. So 3 times 2 to the power of 3 halves. Minus at c is minus 2 over 3 times c minus 1 to the power of 3 halves. Look at here, when c tends to 1 from the right side, this denominator, c minus 1 here. So when c tends to 1, c minus 1 tends to 0 from the right side, as if I have a 0 in the denominator. So c tends to 1 from the right side, c minus 1 tends to 0 as a positive number, meaning that this fraction becomes plus infinity. And I have a double minus here, so the result is still plus infinity. It is plus infinity, so the integral is divergent. You have seen this kind of the last step that I made the argument for finding the limit. You have seen this kind of limits in calculus 1 in the discussion of infinite limits when the variable tends to some number and the whole thing tends to infinity or minus infinity. This is similar to that. So here c tends to 1. Uh, so c minus 1 tends to 0. And with a simple argument, we can see that that fraction 2 over 3 times c minus 1 to the power of 3 halves becomes infinity, and two negatives before that, they neutralize each other, so the whole thing becomes positive. This is a number here, but it doesn't affect plus infinity because when added to plus infinity, it is still plus infinity. So the integral is a divergent integral. Okay, let's see another example. This is an example with tangents. The integral of tangents of 5x as x runs from 0 to pi over 10. Again, I want to determine whether it is convergent. If so, what is the value? Or it is simply divergent. Now, which end number, which of the limits of the integral is making a problem here? If when I let x be 0, tangent of 0 is 0, doesn't have any problem. But what about pi over 10? 5 times pi over 10 is pi over 2, and tangent at pi over 2 is undefined. You know that depending on whether we go from the left or from the right, we might get plus or minus infinity. So tangent of 5x is undefined as pi over 10. For that reason, this is it's an improper integral. And pi over 10 was the problem, so I need to replace pi over 10 with letter C, and let C tends to pi over 10 from left or right? From the left, because pi over 10 is the upper limit of the integral. And the integral of tangents of 5x dx. And it runs from 0, the lower limit of the integral is 0, the upper limit is c. So the integral from 0 to c, excuse me, of tangent of pi over x dx. Before continuing, let's find the integral of tangent 5x. Tangent is what? Is sine over cosine. So this equals the integral of sine of 5x over cosine of 5x. Now that becomes quite simple. Why? Because if I let u be cosine of 5x, the derivative of u with respect to x is, as you know, from using the chain rule, the derivative of cosine of 5x is minus 5 sine of 5x. Why? Because the derivative of cosine is negative sine, and so negative sine of 5x times the derivative of 5x is 5. So I've used the chain rule that you have seen in Calc 1. And in fact, this kind of derivatives were discussed in Calc 1 in the topic of the chain rule. Okay, so du, if I multiply both side by dx, is minus 5 sine of 5x dx. So let's see in this integral what I have. The denominator became u. I need sine x, sine of 5x dx. So down here, I need to divide both sides by -5. So du over -5 is sine of 5x dx. So sine of 5x dx, in fact, is du over -5. So using this substitution that we just did, let's see what the integral will be equal to. Let me continue here. It will be 1 over u du over -5. Let me start from further left, and everything fits here. So it's going to be integral of 1 over u du over -5. -1/5 can be pulled out of the integral. And antiderivative of 1 over u is ln of absolute value of u and plus c, but since it's an indefinite integral, eventually we don't need that plus c. But what is u? U is cosine of 5x, so ln of absolute value of cosine of 5x. So the integral of tangent of 5x dx with this using this substitution is going to be -1/5 ln of absolute value of cosine of 5x, and there's a plus c here, but it's not really needed because we are eventually dealing with the definite integral. Okay, now let's see what we have here now. The limit as c tends to pi over 10 from the left side. We just found antiderivative of tangent of 5x, which was -1/5 ln of absolute value of cosine of 5x. And I need to evaluate at the 0 and at c. So this becomes limit as c tends to pi over 10 from the left. At c, it is -1/5 ln of absolute value of cosine of 5c minus at 0 -1/5 ln of absolute value of cosine of 5 times 0, so just cosine of 0. Cosine of 0 is 1 and ln of 1 is 0. The second parenthesis is just 0 because cosine of 0 is 1 and ln of 1 is 0. So this is just 0. So everything will depend on the first term here. When c tends to pi over 10, 5c becomes 5 times pi over 10, which is pi over 2. And cosine of pi over 2 will be 0. Again, we are dealing with ln of something, which is very close to 0. Since it has absolute value, ln of something positive, very close to 0. As we have seen before, this ln is going to be -infinity. -1/5 times -infinity makes the whole thing plus infinity. Therefore, this integral is divergent. because we got plus infinity as the value of the integral.